The ninth learning objective in section 4.2 is to test a claim about the value of a population mean using hypothesis testing, including checking requirements, writing hypotheses in words and in symbols, finding the test statistic, computing the p-value and drawing the associated distribution, and writing appropriate conclusions. The weights at birth of 5 randomly chosen baby hippopotamuses born in captivity were 75, 99, 107, 82, and 63 pounds. Assume the distribution of weights is normally distributed. Scientists suspect that baby hippos born in captivity weigh more than those born in the wild on average. Past sample data shows that baby hippopotamuses born in the wild have a mean weight of 76 pounds. Using the alpha equals 0.1 significance level, test the claim that hippos born in captivity weigh more on average. Perform the appropriate hypothesis test by stating the hypotheses, calculating the test statistic and p-value, and indicating what decision you would make and what it means. So part 1 says, using correct statistical notation, state the null and alternative hypotheses. So we're going to have a null hypothesis and an alternative hypothesis. These will both be about mu. This is talking about quantitative data, the weight of hippopotamuses, and we're doing a hypothesis test for the mean of all hippopotamuses born in captivity. So the symbol for the population mean is mu. Equal goes in the null hypothesis, and the claim value is the 76 pounds that past sample data has shown is the average for babies born in the wild. Now our alternative hypothesis is this question here. We want to test the claim that hippos born in captivity weigh more. So because it's asking about weighing more, we're going to use a greater than inequality in the alternative hypothesis. Next, it says to report the test statistic rounded to 2 decimal places. We're going to do this in GeoGebra. In order to compute the test statistic and the p-value using one of our procedures in the probability calculator, we need the mean and the standard deviation from the sample. So I'm first going to calculate that. I've entered these 5 weights of the hippopotamuses born in captivity, 75, 99, 107, 82, and 83. I've highlighted those data, and by clicking on one variable statistics, I can compute, create a histogram, and then by clicking on the summation of x button, I can compute the sample size, the mean, the standard deviation, and so I'm going to use those values. Let me slide this over and this over as well. And now I have a window, for the probability calculator opened. I'm going to do the t-test of a mean. The null hypothesis is that mu equals 76. That's the value that I wrote in our h sub 0. The alternative hypothesis has a greater than inequality in it, so I'll click on that button. And now I'm going to enter the mean. The mean of the sample is 85.2. You can see that over here in our output. The standard deviation of the sample is the value for S, which is 17 point, let's enter in 17 point, we'll use 3 decimal places, 838. Our test statistic needs to be rounded to 2 decimal places, so it's always a good idea to use at least 1 extra decimal place until we get to our answer. And then the sample size was 5. Okay, here is our, let me scoot this up a little bit so we can see all of the output. Here's our test statistic. The t is 1.15, and our p-value is given right below it. So first let's enter the test statistic. Which is t equals 1.15, rounded to 2 decimal places. And then next it asks us to report the p-value rounded to 4 decimal places. So our p-value is 0.1565. We can see it right below the test statistic. It says to include drawing, labeling, and shading the appropriate distribution to show the p-value and test statistic. All right, so I'm going to draw a little picture. of a bell-shaped curve, since the t-distribution is bell-shaped. The mean of the t-distribution is 0, and our test statistic was 1.15. And since we had a greater than, I'm going to shade the area to the right of it. That is the area for my p-value. And that area is equal to the p-value, which is given in our output as 0.1565. So next, circle our conclusion about the null hypothesis. Up above, we were told that our alpha significance level is 0.1. Our p-value, 0.1565, is higher than this alpha level, and so therefore our results are not unusual under the assumption that the null hypothesis is true, which means that we will fail to reject the null hypothesis. The next question says, do the data support the claim? Answer with complete sentences, and specifically address the claim. So this is the conclusion that we would make. The data do not support the claim that the mean weight of hippopotamuses born in captivity is greater than the mean weight of hippopotamuses born in the wild, because the p-value is greater than alpha equals 0.1. So therefore, there is insufficient evidence to conclude that the hippos born in captivity weigh more than 76 pounds on average. Our sample mean, as you can see over here, was 85.2. That is more than 76, but it is not statistically significantly more than 76. That could be because our sample size was so small. We only had 5 hippopotamuses. However, given the statistical evidence, we do not have enough evidence to conclude that the claim is correct. Let's look at another example. Electronic scooters have become very popular in large cities, but there is growing concern about their safety. In a study of 190 injuries, the average age of individuals injured was 33, with a standard deviation of 12.9. Perform a hypothesis test to determine whether the average age of individuals involved in scooter injuries is below 35 using a 5% significance level. All right, so let's first write our hypotheses. We will have a null hypothesis and an alternative hypothesis. And again, our parameter is mu. The null hypothesis is that mu is equal to this claimed value of 35. And the alternative hypothesis is that it is below, so that mu is less than 35. Now, to be complete, we should check the conditions. There are 3 conditions that we need to check in order to determine that it is appropriate to do this test on the mean. So let me enter those values in, or those conditions. Here we go. The first condition is that we need to have randomness, either a random sample or a randomized experiment. This is a random sample, and so therefore we've met the random condition. Next is independence. We get that by having the sample size be less than 5% of the population size. And we can assume that 190 injuries is less than 5% of all injuries. And then the third condition is that the population has to be normal, or we need to have a large sample size. Our sample size here is 190, which is large because it is at least 30. We can then compute the test statistic and the p-value using our probability calculator. Our claimed value in this hypothesis test is 35, and I'm going to highlight the less than symbol for our alternative hypothesis. We were told that the mean was 33, the standard deviation was 12.9, and our sample size is 190. This gives us a test statistic of negative 2.1371 and a p-value of 0.0169. So let's write those in. Our test statistic is equal to negative 2.14. We'll round to 2 decimal places. And our p-value is equal to 0.0169. We need to compare the p-value to our alpha level. Our p-value of 0.0169 is less than the 5% significance level that we were told to use. Scroll up so you can see that, 5% significance level. And so therefore we will reject the null hypothesis. Our conclusion is something like this. We reject H0. Since the p-value is less than alpha equals 0.05, there is sufficient evidence to conclude that the mean age of individuals injured using electronic scooters is less than 35.